Hello kids, I'm Chavi Bansal. Hope you already know me. So we have discussed so many topics in physics so far. We have started with the light reflection and refraction. In the last class, we dealt about different concepts related to light, being it a wave nature, ray nature, and laws of reflection. Right? Today we are going to continue that part only. We are going to see how the reflection takes place through a mirror, a plane mirror, or spherical mirrors. Okay. So let me share my screen. Yeah, so my screen is visible, right? So what we have talked about light, nature of light, both as ray nature and wave nature. Sorry. In wave nature, we also discussed about lambda, wavelength, and frequency, right? And we also talked about what are the principles, what are the phenomena which are explained by the ray nature of light, and what are the phenomena which are explained by the wave nature of light, right? Then we studied about the laws of reflection. So laws of reflection, first law states that all the reflected ray, incident ray, and normal should lie in the same plane, right? Same plane. And second was angle I is equal to angle R. Whereas angle I is the angle of incidence and angle R is the angle of reflection. Sorry. So these were the few basic things that we discussed in the last class. On that basis, let's do some questions. Okay. Let's see what the question is given. So the first question is, find out the angle of reflection through the second mirror. So this is first mirror, this is second mirror. So if I extend this, sorry, ray till here, it should get reflected in this way, right? And this will be normal, correct? Sorry. Now we have to find out this angle R. How can we do it? So let's see. Let me take a red color. First, there are two principles. Angle I equals to angle R, and sum of all angles of triangle is equal to 180 degree. Right? So if this is angle I, this is going to be angle R for this ray, first mirror. So if this is 60 degree, this is also going to be 60 degree, right? This overall is a normal. So normal always makes 90-degree angle with the surface. So if this is 60 degree, total is 90. This is going to be 30 degrees, right? Now we have 30 degree, we have 105 by the angle, total angle, sum of this triangle we are talking about, this triangle. We have 30 degrees, we have 105 degrees. We have to find out angle X. This is angle X. This is 180 degree minus 135 degree, which is equal to 45 degrees, right? Now, if this is 45 degrees, this is also normal to the surface, means 90 degree. So this is 45, this has to be 45 degree. And if this is 45, which is angle of incidence for this mirror, this angle of reflection also has to be 45 degree. Okay, so the angle of reflection through second mirror is 45 degrees. Okay, is it clear? Let's see the next question. So in the next question, let's keep this angle as 30 degree. Okay. Now, what are we given? We are given with two mirrors, mirror 1 and mirror 2. Now, both the mirrors are making 30-degree angles to each other, and there is an object placed in between. We have to find out the number of images formed. Such type of questions can be done by the formula 360 degree minus theta minus 1. What is theta? Theta is the angle between the mirrors. So for example, here, it will give you the number of images formed. Okay. For example, here it's 30 degree. So 360 degree by 30 degree minus 1. 12 minus 1, 11 images are formed of this object if two angles are inclined to each other at 30 degrees, 30 degrees. Clear? So these are the questions that we can do on the basis of angle of reflection. Now, what we are going to talk about, we are going to talk about reflection through mirror. In this, first we are going to talk about the plane mirror. Okay. Plane mirror. So this is mirror. Fine. Now there is an object here. Now, before we start talking about the plane mirror and all, tell me one thing. When you stand in front of the mirror, how do you see? You see your height is same as the height of the image formed, right? Height of image formed is equal to height of object, right? Your left is same. Your left is same as the right of the image, right? Your left is same as the left of the image. Sorry. With respect to you, it would be right, but with respect to the image, it will be left. True? Sorry. Now, distance between the object is equal to distance between the image. Before I write all this, let's see. So what I do, I have passed one light ray from the top of the object to the straight mirror. Now what we have done, if anything light falls at 90 degree, here this is the normal, right? And this is the angle of incidence. So angle of incidence is 0 because the normal is parallel or at the same as the incident ray, right? So angle of reflection will also be 0. So the light will retrace its path. Now there is another light. It will come like this, right? If I extend it, hmm, hmm. This is the reflected ray, this is the normal, right? Now, if I extend this is how the reflection is going to take place from the plane mirror. First, the straight line going from the tip of the mirror, tip of the object will be retraced back, right? And the other light, incident ray, fall in the mirror will get reflected by the same angle. Angle I equals to angle R, right? If you retrace the path, you will see these two lines are going to appear to meet behind the mirror, which is at the same distance. If this is X, this is also X, right? Also, what you can see is it appears to meet inside the mirror, right? Behind the mirror. So when we are going to do the image formation and see how the reflection takes place through any mirror, there are certain characteristics we need to write down about the image. For example, we can see distance of object from mirror is equal to distance of image from mirror, right? Next, if you see, this is the tip, right? And from the tip, you can see the tip is formed exactly opposite, right? It means the image is erect. Erect means same as the way it is in the object. It is not inverted, okay? It is erect. Now, image is virtual. What is virtual? Virtual means the rays appear to meet. They are not actually meeting, but they appear to meet, right? So the image formed is virtual. Now, where the image is formed behind the mirror. Okay. So these are the certain characteristics that we can guess from what we have seen here, right? One more thing. With the plane mirror, we see lateral inversion. What is lateral inversion? For example, if I have written O, this O is the object, then the reflection will also be O, right? Because they are same. But if I write B, this is the object, you will see the image like this. It is laterally inverted. Okay, that's why this is the reason. If you see the ambulance, the name ambulance written on the ambulance is written in a laterally inverted way. So that whosoever is driving in front of it, if they see it in the rear view mirror, they will see the correct word called as ambulance instead of the other way around. So to make it clear and so that the people can give way to the ambulance, the name of ambulance written on the ambulance vehicle is written in a laterally inverted manner. Okay, so the plane mirror show lateral inversion. Is it clear? This is about the reflection through the plane mirror. Next, we are going to talk about spherical mirrors. What are spherical mirrors? So basically what happens, this is the whole sphere. Right? If any part of it, like for example, this part of it is cut, then it is called as a spherical mirror, right? So this spherical mirror would have a center, right? This would have a center. This point is called as C, center of curvature. Now, if this part is cut, this part of the mirror is taken. It means this side, this is the polished side, and this is the reflecting side. Okay. Same way, there is another mirror, spherical mirror. If this part is taken, and this is the polished side, this is the reflecting side, then they do both are spherical mirror. They both different type of spherical mirror. This mirror is called as concave mirror. Whereas this one, where the reflecting side is outside, outwards, and the polished side is inward, is called as convex mirror. Concave mirror or convex mirror. Let me take this mirror separately outside. So if this is the mirror, this is the polished surface, and let me draw the center of curvature, C. Okay, this is called as concave mirror. Like how in the cave light enters, right? This is the cave and the light enters from this side. Same way in concave, cave is written means concave, cave shaped. In the convex mirror, sorry, this is the convex mirror. This is the polished side. And obviously this will be the center of curvature, C. Fine. Let me draw it straight. This is center of curvature. This is concave mirror. This is convex mirror. Now, on the axis where the center of curvature lies is called as principal axis. This is called as principal axis. And the point where this principal axis meet the mirror is called as pole. P or pole. Same way, this is pole, P, and this is principal axis. Okay. Now, there is another point on both the mirrors, which is called as F. F stands for focus. Focus. What is focus? Focus is a point on the principal axis where either the light rays after getting reflected actually meets or appear to meet. Okay. What is focus? Focus is the point on principal axis where light rays after reflection actually meets or appear to meet. And if you see this focus F is equal to C by 2. The distance from the pole to the center is, for example, C. Then the focus is C by 2. Means the distance, the focus is always present to half of the radius of curvature. Half of the radius or the distance from center to the pole to the half of it, focus is present. Okay. This is what focus is. Are we clear? The 3 points, principal axis, concave mirror and convex mirror. See, when the cave, how does cave look like? This is the cave. Cave is never this way, right? Cave, you enter from this side. So how the light enters into the cave? This is how the light enters in the cave. So this is concave. The other way is convex mirror. This is convex mirror. Okay. So in concave mirror, there are, in both concave and convex mirror, there are 3 points. Center of curvature. C is center of curvature. P is pole, and the line joining the center of curvature to the pole is called as principal axis. Okay, what is focus? We already did. It is a point on the principal axis where light rays after getting reflected meets actually or appear to meet. And the distance of focus is equal to the half of the distance between the center of curvature and pole. Clear? These are two types of spherical mirrors which we are going to study in detail. Now, before we study or start seeing how the image formation takes place from both the mirrors, there are certain rules that we have to follow. Rules of image formation. First rule, any ray parallel to principal axis will pass through focus after reflection. What do I mean? For example, this is a concave mirror, right? This is principal axis. This is center of curvature, P. This is focus. Any ray, this is the ray which is parallel to the principal axis. After reflection, will pass through focus. Okay. Same way for convex mirror. This is center of curvature. This is pole. This is this is focus. Any ray coming parallel to the principal axis, here it is not passing through focus actually, but it will appear to pass through focus. Okay. This is how it will. This is the first rule for making the image. Fine. Second rule. Any ray passing through focus will be parallel to principal axis after reflection. Means what? Any ray. Here, in the first case, the ray incident rays were parallel to the principal axis. In this case, we are saying if a ray incident is passing through the focus after reflection, it will become parallel to the principal axis. It's the opposite of this one. Let me show you. For example, concave mirror. C, F, P. Now, this is a ray. It is passing through the focus. After reflection, it will become parallel to principal axis. Same way with mirror. C, F, P. Now, any ray which passes through the appears to pass through the focus will become parallel to principal axis. Okay. These are the two rules. Third rule, any incident ray passing through center of curvature will retrace its path. Means what? For example, this is the concave mirror. Sorry. This is C, F, P. If any ray comes this way, it will retrace its path. Okay, because the line that is passing from the center falling on the mirror will be a normal to the mirror. Normal means 90°, and whenever the angle of light with the mirror is 90°, it is going to retrace its path. Same way here, focus, center, it will retrace its path. Clear? Fourth point, any incident rate fallen on pole will get reflected by the same angle. Means, for example, this is the mirror, this is principal axis, pole. If a light is coming like this, it will get reflected this way. This angle I and angle R is equal to same, like they are same to each other. Okay. These are the four rules for making any image, any type of image. Okay. So these are the rules that we have to follow while making the image from both concave and convex mirror. And these rules are very, very important. Clear? Any doubt? Let's see the image formation now. How does the image is formed? So let's do concave mirror first. Image formation by a concave mirror. In this, we have 6 different cases. We'll study all the 6 cases. Okay. Let's take a concave mirror. P, C, F. Case 1. When object is kept at infinity. Now, what is infinity here? Infinity means any distance which we are not known. And it should be greater than the distance between center of curvature and pole. Okay, unknown distance, which is very, 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 very far away. Okay, very far from the mirror. So when the object is kept at infinity, the rays coming from the object will be in parallel to principal axis. And we know, according to the first rule, any ray parallel to principal axis will pass through focus after reflection. So all the rays will pass through focus after reflection. Right? This is how it is. Okay. Now, if you see, all the rays are converging to focus. Now, we have to write down the nature of image formed. So first is where the image is formed. It is formed at focus. Now, what is the size of image? If it is coming from infinity, there should be certain length or certain size of the object, right? But the image formed is very point size. Okay. So highly diminished. Diminished means small. Highly diminished, exactly point size. Third, the image formed is real. Now, what is real image? To understand the real image, there are two things. First, light actually meets. Second, you need a screen to see the real image. What does this mean? Now, image is not formed on the mirror, right? Image is not formed behind the mirror. If both the cases, we can see the image in the mirror itself. But here, the image is formed at focus, which is before the mirror. To see that image, we need to have some screen, some paper, something to see where the image is being formed. Okay? So that is real image. Fourth, if there is any height, very small height also, which is present at the focus, it will be inverted. What does inverted means? For example, this is your object. Then this is the image formed. Means upside down. When it is upside down, rotated, it is called as inverted image. Is it clear? We got to know about the nature of the image formed by the concave mirror when the object is kept at infinity. Clear? Any doubt? Next case. Case 2. Object is kept beyond C. Let's take the mirror. Now this is pole, this is focus, this is C. Now object is kept at beyond C. Beyond C means the distance should be larger than the distance between center of curvature and pole. And this distance should be known. In previous case, the distance was unknown and it was very, very huge. Here the distance is more than the center of curvature. Okay. Now let's pass one ray parallel to the principal axis. Okay. It will pass through focus. Fine. Another ray, let's take it from focus only. One second. And let's see how it reflects. It will become parallel to principal axis. Okay. Fine. Now, you see these two rays are meeting at this point. So the image will be formed at this point. Okay. Why is it so? Because see, these two rays are coming from the tip of the object. So that wherever they will meet will be the tip of the image, right? Now for the ray, for example, rays are coming from the bottom of the object. It is perpendicular to the pole. It will retrace its path. So here only the image bottom will be formed. Fine. This is how the image will form. So what is the nature of image? First, where it is formed between center of curvature and focus. Second, the height. If you see, the height of object is high more than the image, right? So it is diminished. Not highly diminished, but diminished. Third, is it a real image? Yes, it's a real image. Why? First, it is being formed in front of the mirror and the focus, the rays are actually meeting at this point. Fourth, it is inverted because it is upside and down, right? This is the second case. Let's see the third case. Third case, in the third case, the object is kept at C. Focus, pole, C. Third case, object is kept at C, like this. Okay. Okay. This should be C. Then object is kept at C. Now, how the image formation will take place? Let's pass the ray parallel to principal axis. It will go through the focus. right? Next, let's pass through the focus. Let's see how it goes. One second. Because these are not measured with the scale. If you do it with the scale, you will get the exact time. So you will see the image will be formed at point C only. Okay, let me retrace it. Mhm. One second. Oh, something like this. The point will be shifted. You see the image is formed at C only. When you draw it with the scale, you will see the image formation takes place at C. So what is the image formation? Image is formed at C. Second, same size. Third, real. And fourth, inverted. Right? Very easy, right? Let's do one more case. Fourth case, object at uh, object between C and F. Mhm. F, C. Okay. Now the object is kept between F and C. Again, let's draw a line. Okay. Let's draw the other line, just passing through the um, oh, yes. So if you see, so this is the case. You see here, the image will be formed beyond C. Okay. It is not looking right now, but the image form will be beyond C. Okay. So how is the image? First, beyond C. Second, enlarged, right? The image formed here is enlarged image. Third, enlarged image, right? Third is again real and inverted. Clear? Next case is fifth case. Object at focus. P, C, F. Now, the object is kept here. Okay. First, let's pass parallel. It will pass through focus, right? Next, we can pass it through the center of curvature also. We can also pass it through. Okay. If we see what happens, both the rays, after when it passes from center of curvature, it traces its path, right? So both the rays, if you see after reflection, are parallel to each other. Parallel, right? And we assume the parallel rays meet at infinity, right? The parallel rays will meet at infinity. So how is the image formed? First, it is formed at infinity. Second, see, it is going down, 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 right? If it is going down, imagine at infinity how down it would have gone, how enlarged the image will be. So it will be highly enlarged. Will it be real? Yes, because rays will actually meet there. Real, and the image again will be inverted. Okay. This is the case when the object is kept at focus. The last case, very, very important case, which has many uses also in our day-to-day life, object between focus and pole. This is pole, this is center of curvature, this is focus. Now the object is kept here. Okay. Parallel line will always pass from, or let's pass a line from the pole itself. Okay. Then a line from center of curvature. Right? Now you see these two lines are divergent, means they are going spreading away after reflection, right? It means they are never going to meet this side, but if you extend it this way, they will meet behind the mirror. What do? They will meet behind the mirror. Appear to. They will not meet actually, but it will appear to meet at behind the mirror. If you see inside the mirror, you will see that the image is enlarged and it is formed inside the mirror. Okay. So how is image formed? Image formed behind the mirror. Second, how is it is? It is enlarged, right? See the size of object, see the size of image. Enlarged. Third, is it real? No, the image is virtual. Means the lines are not meeting actually, they appear to meet. And fourth, is it inverted? No. From the tip is formed, right? If you see, it is an erect image. Erect means it is not inverted. It is not upside down. It's same as the object, right? So this is the very important case of concave mirror. Why? Because see, if you put any object in between the focus and pole, you will see the enlarged image. So for example, you are using a magnifying glass, or for example, you are using any glass to see very small things, then this kind of mirror is really useful because it will show the enlarged image of the small object, because of which you will be very much visible from the naked eye. Okay. So these are the 6 cases for concave mirror. Is it clear? Any doubt? Let's see the convex mirror. Convex mirror, in this we only will do 2 cases. Okay. So convex mirror will only have 2 cases. So in convex mirror, we'll see only 2 cases. Let's draw it. Okay. Case 1, object at infinity. This is pole, this is center of curvature, this is focus. Now, if image is at infinity, the rays coming from the object will be parallel. Parallel to principal axis. Right? Now, these rays are coming parallel to principal axis, and according to the law, we know that any ray, if it is coming parallel to the principal axis, it has to pass through focus. Now, these rays cannot pass through focus, right? So what we'll do, they will appear to pass from focus and get deflected. This way. Like this. Okay. So this is, they will not pass through focus, but they will appear to pass through focus. Now, how the image is formed? It is formed at F. right? Second, how is it? It is highly diminished. Is it real? No, it is a virtual image. Why? Because it is appeared to meet, but it is not meeting. And if you see, if it has any small height, it will be an erect image. Okay, this is the first case of convex mirror. Case 2. Case 2, object at known distance, any distance but known between infinity and pole. Okay, then what will be the case? Destroyed. This is center of curvature. This is focus. This is pole. Let's put the object here. So first, ray parallel. If the ray is parallel, it will appear to meet at focus. Means it's right. Let's put the second ray to the pole. So pole wala we know it goes back at the same angle. So this is the image. Now, if you see, if I retrace this, this is where it appears to meet, right? So the image will be formed here between pole and focus, right? Now, how the image is? Image is formed between pole and focus. Second, it is diminished. It is not highly diminished, but it is diminished, right? Third, it is a real image. And fourth, it is an erect image. In case of convex, we do not have objective center of curvature objective focus because these are on the other side of the mirror. We can only know at the infinity and a finite distance between infinity and pole. So these are the two cases of convex mirror. Are we clear? Oh, the very important case is this sixth case of concave mirror. Other than that, everything is very easy. This is also very easy, but this is highly recommended. Fine. Now, if you see the reflection, no, what we can say, concave mirror is convergent, right? If you see, everything is getting converged. You know, many rays are coming, they are getting converged to a point. Whereas convex mirror is divergent. So accordingly, they are used. So convex mirror is used in night lamp where, you know, a source will diverge the light, right? They are also used in street lamps. They are also used in rear view mirror and all that. Whereas concave mirror, this sixth case, as I told you, is used in magnifying the nearby objects. For example, magnifying glasses, or for example, anything, makeup glass, makeup mirror and all that. These are used for magnifying the image which are object which are kept at between focus and pole. That's why they keep moving it so that the object folds between pole and focus so that the image that is formed is magnified. Clear? These are the cases of image formation from the mirror. I hope you are clear with all the cases. If you have any doubt, please put it in the comment section. And if you like the video, please share, subscribe, and share it with your friends also so that they are able to understand it as well. Okay. Thank you so much.